Okay, Chapter 1, Section 7, the last section in Chapter 1, problem solving, and it covers interest, mixture problems, uniform motion problems, and what they call constant rate jobs. It's when you get one job done. The first objective is to translate verbal descriptions into math expressions. I'm just going to write this because I don't need to write it down. Into math equations or expressions, I guess is what they say. And I think you know how to do that perhaps pretty well. The other objectives, the 2, 3, 4, and 5, is really solve applications. Which involve those types of problems in the name of this section. So we're going to do one of each one of those, and as we go we'll be translating this. So it'll be, I guess, objective 1 is going to be used over and over. So if you want to follow along, page 146, the exercise set, I'm going to pick some even ones. The first one is number 16. It's what they call a business application. It says the total revenue derived from selling X dishwashers is $250 per dishwasher times the number of dishwashers sold, and the directions are write as a mathematical equation. And when you do that, you usually have to choose what your variable is and what it stands for. So I'm going to let X be the number of dishwashers sold. And we're supposed to take this statement and turn it into a mathematical equation. Remember, it is, let's see here. The total revenue derived from selling X dishwashers is $250 per dishwasher times the number of dishwashers sold. My gosh, it's a long statement. But you can, I guess, reduce that a little bit. And if we need 4 steps, you can at least put your reduced part here. So I need the total revenue, and then it'll have some blah, 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 is $250 times the number of dishwashers sold. And that's what we're supposed to translate into an equation. So the total revenue, I guess we can call that R, is the equal sign, $250 times the number of dishwashers sold, which we called X. So there's an equation. Since we're not given any numbers, we really have R of X if you wanted function notation. We'll talk about that later. The revenue is 250 times the number of dishwashers sold. And that's all they really wanted. But we need 4 steps. So we got to the business, write it in math equation. What did you choose X for? The statement, and then the equation. So we're done with that first interest problem. Mixture problems. And we're going to do number 22. This is blending coffee. Now, For most of these mixture problems, and they can come in different forms, this is mixing two kinds of coffee to get a new coffee. The first coffee that we're mixing together is the 275 blend. Don't have the name for that, I guess. The other coffee is the $5 blend. I'm going to put a couple of zeros so it looks the same. To get a $3.90 blend, they tell us that we should use 100 pounds for the total of our blend, the final new blend. That means we get to choose X for one of these. What do you want to choose X for? Well, let's call it the number of pounds for the 275. Now we know that this is going to be X pounds, and this will be 100 minus X. That's going to be a common use of this total minus the part. That means we're down to just this one variable. But all of these mixture problems, if you set them up this way, and it could be money you invest, it could be peanuts, it could be candy, it could be anything that they talk about putting two things together for a total, you can use a mixture. And this is just multiplication. The 2.75 times X plus the 5, I'm going to put 0.00, times 100 minus X equals the 390 times 100. And then you solve that. But notice we've got 4 steps already here. Let's see. 2.75x. Let's distribute this. 5 times 100 is 500. 5 times a negative x is negative 5x. And this equals 390 times 100, which is 390. Oops, 390 decimals there. So this is a negative 5 and a positive 2.75. So if we subtract the two, if we take 5.00, 275, these are whole numbers now. 10 is 5, so this would be 9 is 2, and 4, so it's 225 together, or we don't need the decimals. Let's see. Yeah, we do need the decimals because that's the 5. Okay, so this is a negative 2.25x plus 500 equals 390. Negative 2.25x. What is 390 minus 500? Well, really, what is 500 minus 390 and make it negative? 0, 10, see, 10 minus 9 is 1, and 4 minus 3 is 1, so that makes sense. 110. Negative, though, because you're subtracting 500. Now the negatives are going to cancel. And we can divide along division, or you can use your calculator, and you get x is equal to 48.888 repeating. So we should probably then round this to the, let's see, this is the x is for the number of pounds. Maybe we round it to the nearest pound. I might have to tell you what they round it to. Does the problem say what amounts of each? Doesn't really say. Let's round it to the nearest pound. So x is going to equal 49 pounds. And the other is 100 minus 49, or 51 pounds. That's interesting. So 49 pounds, 51 pounds, almost an even split. That might be a different question for a different problem. Blending, mixture problems. I like the pictures. It also gives me a step, at least one, maybe even 2, you could count that. The next. Number 28. Two cars enter the Florida Turnpike at Commercial Boulevard at 8 a.m., each heading for Wildwood. One car's average speed is 10 miles per hour more than the others. The faster car arrives at Wildwood at 11 a.m., 1/2 hour before the other car. What was the average speed of each car, and how far did it travel? So, let's see here. We can write a lot of that down, but really we need a picture. We're entering this highway, and maybe I should enter one from another side, just so this will be car A and car B. This is at 8 a.m. Car A is going down here. Car B is also going down here, but it's going faster. Car A will say, let's see, what do we want to let X stand for? So X will be the speed or rate of A. And X plus 10, because it's going faster, is the speed of B. So, let's see, and this is the distance D. What is our famous formula for distance? This uniform motion. Distance equals rate times time. Some people call that DIRT, D-R-T. So, we need to get an equation, though. Sometimes you can say that you've got the same time. This does not. Sometimes you can say you've got the same distance. This one does. Sometimes it's the same rate. This one's not. So the rates are different. What about the times? If we call this time t for A, then for the speed of B, this is t minus 30 minutes, right? But remember, we have to do this time in hours. So let's see. When did they arrive? The first car arrived at 11. So it took the B from 8 to 11, or 3 hours. And it took A 30 minutes longer, 3.5 hours. So we've now got the rate times the time, and we can make the distances equal. So the distance for A equals the distance for B. The distance for A is a rate for A, which is x, times the time, which is 3.5. The distance for B is the rate for B, x plus 10, times the 3. And now we've got this equation. So this is 3.5x, and if we distribute this 3x and 30. Let's subtract 3x from both sides. We get 0.5x equals 30. Divide by 0.5. So when you divide by 1/2, you really multiply by 2. So this is really 60. So x, which stands for the speed of the car, is 60 miles per hour. And x plus 10 would be 70 miles per hour. So the speed of A is 60. And the speed of B, which is supposed to be 10 miles an hour more, is 70. Hopefully they're still within the speed limit. The distance, though, both of them did the same distance. We could use either speed times their time. Since the speed of B has got the time 3, let's do the 70 times the 3, or 210 miles. So we've got the speeds, we've we've got the times. Sort of fun. So the last one is these job problems. We're going to do number 34, but I forgot to tap the screen first. Let me move this back up. Okay, tap the screen. These problems are really the rate of 1 times the time of 1 plus the rate of 2 times the time of 2 equals one whole job. This is different from that distance equals rate times time. That was a distance. This is going to equal 1 for these jobs to get done. And that's what sort of I always wondered about that. It's because this is part of the whole job. This rate is how much they can do in an hour or a minute or whatever the unit of time is. But this idea is going to be helpful. So we need Trent. He delivers these papers in 30 minutes. So the rate, R1, is 1 over 30. So if we talk about minutes here, he gets 1/30 of the paper route done in 1 minute. That's the rate. Lois is faster. I don't know if they use a bike, maybe she just walks faster. Delivers in 20 minutes. So the rate 2 is really 1 over 20. Now, if they want the time together, that means one's not out there longer than the other. So the time T1 and T2 are the same, so I'm just going to call it T. So the rate for 1, 1/30, times the time, plus the rate for 2, which is 1/20, times the time, and this is what always got me as a student, equals 1. This is one job done. We get this fraction of it done. Lois gets this fraction of it done. Together, they have the whole job done. That's the best way to think of it, I think. So T over 30 plus T over 20 equals 1, but I'm going to write this, well, okay, we'll write it as 1 right now. If we get a common denominator, though, let's see, times 2 to get 60, and times 3 to get 60. So this is really 2t over 60, and this is 3t over 60. Now you can have it equal to 1 if you want to, but we can write 1 as 60 over 60. If everybody's got the same denominator, just so there's no variable there, we can really just forget about the denominator. And we can get that 5t equals 60. That's the same as multiplying both sides by 60. Same thing. Divide both sides by the 5, and t, the time for them to do it together, is 12 minutes, which makes sense. And that's one of the things in those steps that you would find back on page, let's see what, it's the blue box on page 140. That last step is one that you may not do as often as you should, myself included. When you're all done, does this at least make sense? Well, if Lois does it in 20, then it's not going to certainly take more than 20. And it may not take half because Trent's not as fast, so a little bit more than half would be a right number. How much more? Well, just that 2 minutes is what we're saying. So at least logically, it makes sense. So when you're doing these, don't just get done and say, I'm done. Look at the answer and see if it at least makes sense. And these are sort of fun problems, so have a good time working all these. Section 1.7, and we'll be done with chapter 1 then.